Hey, good people. Arthur Morris here. Hope all is well. In this video, we're going to look at the product and quotient rules and higher order derivatives. So we want to find the derivative of a function using the product rule, using the quotient rule. We'll look at a few trigonometric functions and the higher order, maybe the second derivative. Okay, so Theorem 2.7, the product rule, says the product rule of two differentiable functions f and g is itself differentiable. So to find that derivative of the product of two functions, then we use this little formula here that says we multiply the first times the second derivative and the second times the first function's derivative. So the first function times the second function derivative plus the second function times the first function's derivative. Alright, so using the product rule on number 2 here, we have y equals 3x minus 4 times x to the third plus 5. And if you're looking at your formula up here, you're treating that 3x minus 4 as f of x and the x to the third plus 5 as g of x. So to find our derivative of f of x times g of x, then that's going to equal the first times the derivative of the second plus the second times the derivative of the first. Alright, so the first, 3x minus 4. So 3x minus 4 times the derivative of 3 or x to the third plus 5. So the derivative of x to the third is 3x squared. And remember, your derivative of a constant is 0, so just 3x squared. Plus the second function, x to the third plus 5, times the derivative of the first function. Your derivative of 3x minus 4 is simply 3. Remember, you multiply 1 times 3 is 3, subtract 1 from the exponent, and your derivative of a constant is 0. Alright, and then we want to clean this up a little bit. So let's distribute and combine like terms. Okay, so it looks like we can combine the 9x to the third and the 3x to the third. And that's it. Okay, so again, the first times your derivative of the second, and the second times the derivative of the first. So number 5 here, we have f of x equals x to the third times cosine of x. So our first function is x to the third. Our second function is cosine of x. Remember, your derivative of cosine of x is negative sine of x. So first function, x to the third, times the derivative of the second function, derivative of cosine of x is negative sine of x, plus the second function, cosine of x, times the derivative of the first function, 3x squared. So now f prime of x equals negative x to the third sine of x times sine of x plus 3x squared times cosine of x. And if you wanted to, you could clean that up a little bit more if you chose to by factoring out an x squared, but however, I don't think that's necessary. Alright, the quotient rule. The quotient rule, same thing. If it's differentiable, if the function is differentiable, then the quotient is differentiable where g of x cannot be equal to 0. So we'll use this formula here, and we use a little saying of low D high minus high D low all over low low, which means low being your denominator and high being your numerator. So the low function times the derivative of the high function, derivative of your numerator, minus the high function or your numerator times the derivative of your low function. So we use the saying low D high minus high D low all over low low to help us remember this. So your denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over your denominator squared. Alright, let's look at number 7 here. So f prime of x, low or your denominator, times the derivative of the numerator. Derivative of x is simply 1. Remember, we would we have that 1 there. It will come down, subtract 1 from the exponent, so derivative of x to the first is simply 1. Minus your numerator, or high, times the derivative of your denominator, or d low. So derivative of x squared plus 1 is 2x. All over low low, or your denominator squared. Alrighty, let's clean this up some. Let's simplify our numerator. So x squared plus 1 minus 2x squared. And then combine like terms. So we have negative x squared plus 1 all over positive x squared plus 1 squared. So we cannot simplify that any more than the numerator and denominator because the x squares have different signs there. Alrighty, let's look at number 8. Okay, so again, we're going to use the quotient rule. So low D high, derivative of 3t squared minus 1, 2 times 3 is 6t, minus high D low, derivative of 2t plus 5, 1 times 2 is 2. So subtract 1 from the exponent, so the t's are going away. And remember, derivative of a constant, that 5 is 0. So 2t minus 1, derivative of that is just 2. All over low low, or your denominator squared. Alrighty. So now let's go ahead and start cleaning that up. Distributive property, multiply that through and combine any like terms. So distribute that, minus. And let's go ahead and distribute, multiply it by 2 while we do that. So let's take care of two things at once. So let's make that minus 6t squared plus 2. Alright, combine like terms. So we have the 12t squared and the minus 6t squared, so that's 6t squared. And we'll leave it there. And we could factor out a 2, but again, that won't do us any good, so we'll just leave it there. All right, let's see. You may want to pause it there if you need to write that down. All right. Let's move right along, and now we have find the derivative of the algebraic functions. Okay. So I'll tell you this: if you can simplify, then simplify first before you try to find a derivative. So if you can simplify the function first. So how about we rewrite the numerator, rearrange it. So descending variable order there. And let's see here. How about we factor out a negative from the numerator. Factor out a -1. So that makes positive x squared plus 3x minus 4. Okay. And then let's see if we can factor the numerator and denominator. So factors of -4 that equals 3 would be +4 and -1. And then in our denominator we have the difference of two perfect squares. So using our basic factoring rules for the trinomial and the difference of two perfect squares, you have to practice your algebra. I'll say that over and over and over again. Algebra is very important in calculus, so you have to continue to practice on your algebra. All right, so now we can cancel the x minus 1s. Then I think I'm finally ready to, let's go ahead and distribute that negative through there. So let's make that -x minus 4. I think we're finally ready to find our derivative. So we'll use low d high minus high d low over low low. So we've simplified the function. Now we want to find the derivative of this simplified version of our original function. So quotient rule, low, so x plus 1. Derivative of our numerator, derivative of -x minus 4 is -1. Minus high, and then times the derivative of our denominator, which is 1, all over our denominator squared. Okay, and let's clean it up. So distributive property, -x minus 1 plus x plus 4 like terms. Looks like the x's go away, and -1 plus 4 is +3. Okay. All right. You might want to pause it there if you need to write that down. Okay, let's move up to number 29 here. Okay, so we have f of x equals 3x minus 1 over the square root of x. All right, now you gotta work with me here. So the first thing we need to do is to change that square, or the square root of x, put it in exponential form. So x to the 1/2 power. All right, after we put it in exponential form, I think we're ready to use our quotient rule. Okay, so low d high, so low, x to the 1/2 power times the derivative of the numerator minus numerator times the derivative of our denominator. So 1/2 times x subtract 1, which is the same thing as subtracting 2 over 2. So it gives us x to the negative 1/2 power. All over our denominator squared, or low. All right, so let's see if we can clean this up some. All right, so we have f prime of x equals x to the 1/2 power, and let's distribute this 1/2 x to the negative 1/2 along with that negative. So let's distribute that. Let's see what we come up with. All right, so negative 1/2 times 3 is 3/2. X to the first times x to the negative 1/2. When you multiply like bases, you add the exponents. So 1 minus 1/2 is simply 1/2. Okay, now let's distribute the 1/2 x to the negative 1/2 to negative 1. So that's just going to change the sign and make it plus 1/2 x to the negative 1/2. Okay, looks like we have like terms maybe. Let's see here, x to the 1/2 power. So we have some like terms we can combine. Let's go ahead and finish our denominator. 1/2 squared, that will give us exponent of 2 over 2, which will just be x to the first power. Alright, so let's combine those like terms now. So we have 1 x to the 1/2 minus 3 over 2 times x to the 1/2. So that 1, if we get common denominators, it's the same thing as 2 over 2. So that 2 over 2 minus the 3 over 2 would give us negative 1/2 x to the 1/2 plus 1/2 x to the negative 1/2 all over x. Okay. All right, how about we clear the fractions out of our numerator? And guys, I made a mistake. We need to go back and clean this up just a little bit. The derivative of 3x minus 1 here, instead of 1, that should be 3. So let's clean this up. That should be 3x there. Sorry about that. And still get a common denominator, so that would make 6 over 2 here. And then that would give us 3 over 2, 6 over 2 minus 3 over 2 here, those like terms. That will give us 3 over 2 times x to the 1/2 plus 1/2 x to the negative 1/2. I'm so sorry about that. Alright, let's clear those fractions out of our numerator. And let's do that by multiplying by 2. So whatever you multiply the numerator by, to keep this balanced, you need to multiply your denominator by the same thing. Alright, so now we have 3x to the 1/2 plus x to the negative 1/2 all over 2x. And the computer very well may take that answer. I'm going to take this a little bit farther and see if I can't clean it up a little bit more. So let's see, f prime of x. I'm going to split this up and make 3x to the 1/2 over 2x and x to the negative 1/2 over 2x. So I'm just going to make that into two separate fractions. And then I'm going to use my quotient rule for exponents. It says you subtract the exponents. So since I have the exponent of 1/2 in the numerator and the exponent of 1 in my denominator, I'm going to subtract 1/2 from that 1 in my denominator. That gives me 3/2, and that's 2/2 minus 1/2 to the 1/2. And then I'm going to do the same thing here. If I subtract 1/2, that's the same thing as adding 1/2. So that gives me 2, and if I add 1 plus 1/2, that's 1.5 or 3/2, x to the 3/2. Like I said, the computer may take that answer in that version. I'm just going to clean it up a little bit more. Then the final thing I'm going to do is get a common denominator. I have x to the 1/2 and x to the 3/2. If I multiply by x to the first, then again I have that 1 plus that 1/2, which will give me 3/2. So I'll get 3x over 2x to the 3/2 plus 1 over 2x to the 3/2. And finally, I would have 3x plus 1. I can combine this into one fraction because my denominators are the same, like so. So I may have done a little bit of extra work to clean that up, but hey, it works out. And that's a lot of algebraic work in there. A lot of algebraic work in there with those exponents. All right, so moving on. All right, so we have derivatives of trigonometric functions, and I just put on this page a few extra derivatives that you need to be aware of. So far as tangent equals secant square x, and secant of x equals secant x tangent x, cotangent of x equals negative cosecant square x, and cosecant x equals negative cosecant x times cotangent of x. All right, number 41 here, we have f of t equals cosine of t all over t. So we're going to use our quotient rule here. So low, or our denominator, times the derivative of our numerator. Derivative of cosine is negative sine of t minus high cosine of t times the derivative of our denominator of t, which is just 1. All over low, or our denominator squared. And then we'll just clean this up just a little bit. So negative t sine of t minus cosine of t all over t squared. Alrighty. F of x equals sine of x over x to the third. So again, you may want to pause the video and try this one yourself using the quotient rule. All right, let's look at it. So we have x to the third times the derivative of our numerator. So derivative of sine is cosine of x minus sine of x times the derivative of our denominator, which is 3x squared, all over our denominator squared. So low d high minus high d low all over low. And then again, as usual, we want to clean this thing up. So x to the third times cosine of x minus 3x squared times sine of x all over x to the 6th power, power to a power rule of exponents. And if you want to clean this up, you surely can clean this up some, and I probably would here. Looks like we have x to the third, x squared, and x to the 6th, so we could actually factor out an x squared. We factor out an x squared from our numerator and denominator, and then cancel it out. So that would leave us with x cosine of x minus 3 sine of x all over x to the 4th. Alrighty, let's look at the second derivative of a function. Now, the first derivative represents speed or rate of change. Second derivative represents acceleration. At any given point. So we can find the acceleration at any given point on that function. Okay, so to find the second derivative is fairly simple. You find the first derivative and then you find the derivative of the first derivative. So our first derivative (4x to the third plus 6x squared minus 6x minus 1). And then to find the second derivative, you just find your derivative of the first derivative. So first derivative is slope or rate of change. Second derivative represents acceleration. And remember that your derivative of a constant is 0, so that would be the second derivative of the function. Alrighty, and last but not least, number 93 here. Want to do the same thing, find the second derivative. So to find the second derivative, find the first derivative, and then find your derivative of the first derivative. So f prime of x. So we have 3/2 times 4 times x subtract 2 over 2. So x to the 1/2. And then simplify that. So f double prime of x, well, we can simplify. Yeah, let's simplify it first. So f prime of x equals 6 x to the 1/2 power. And then your second derivative, just use that power rule again, that exponent rule again. So 1/2 times 6, subtract 2 over 2 this time. So that's negative 1/2. So 3, and then to make that exponent positive, I'm going to move the base to the denominator. And there you go. Alrighty, good people, that's a wrap for this video. I hope you found it to be helpful, and I will see you on the next one. Thank you.